Imagine an 8th century laboratory where absolutely every surface is buried under bubbling liquids, raw ores, and strange powders. In this era, if a scientist couldn't identify a substance immediately, they treated it as a unique mystery, unrelated to anything else. This made it nearly impossible to compare findings or build on previous discoveries. Scholars tried to fix this by grouping materials based on how they looked, putting all the shiny rocks in one pile and all the yellow powders in another. But grouping by color or local myth is unreliable. It forces a scientist to rely on guesswork, which prevents any consistent, shared understanding of how these materials actually work. Jabir ibn Hayyan believed there was a more reliable way to bring order to this chaos. He proposed a different standard. Stop categorizing substances by their surface appearance and start measuring how they behave when subjected to extreme conditions. This shift from looking to testing created the first systematic method for studying the physical world. To see how this worked, imagine taking that entire collection of unknown substances and placing them over a heat source. At low temperatures, a specific set of materials, like camphor and mercury, reacts immediately. They turn into vapor and rise out of their containers. Jabir called these spirits, separating them for their ability to vaporize. We recognize these today as volatile substances. When the remaining solids are subjected to intense fire, a second group reveals itself, resisting melting until the heat is extreme. This category included gold, silver, copper, and iron. They shared a specific set of physical rules that set them apart from the vaporizing spirits. Jabir spent years recording the exact weights, hardness, and melting points of these metals, comparing them side by side. By identifying these shared characteristics, he provided the data that future scholars use to refine ores and develop early material science. After the spirits have vaporized and the metals have melted, a third group of materials remains in the crucible. These substances don't melt into liquid or turn into gas. Instead, they might crumble into powder, dissolve in liquid, or react in their own unique ways. Jabir placed these minerals and salts into a final category, labeled stones. Look at the difference. The scattered cluster on the left is replaced by the specific, actionable columns on the right. Grouping these stones together allowed scientists to isolate and compare the properties of different salts and ores without the confusion of the previous centuries. This organization meant that chemical knowledge could be recorded, preserved, and accurately shared across generations. By sorting materials based on their reactions to stress, Jabir converted a room of curiosities into a library of predictable results. While a three-part system is simple by today's standards, the specific categories aren't as important as the logic behind them. The shift was the decision to categorize matter by its observable behavior, rather than its appearance or the tradition of the time. This same approach defines the modern chemistry classroom, where substances are organized by their properties, as acids, bases, metals, or nonmetals, long before an experiment begins. While modern systems are vastly more complex, they still rely on this shared premise that substances with similar behaviors belong in the same group. This structure is what gives scientists the ability to predict how a new substance will react before they ever touch a flask. Jabir ibn Hayyan didn't simply add to the list of known substances. He established the methodology for organizing all future ones. Bringing order to matter based on evidence turned a collection of scattered observations into the foundation of a global science.